All right, let me get this guy all set up here. So, Chapter 5, we finished it off last time. Was there anything you need to still go over? Well, Chapter 5, we did division last time, and did it work out okay? We had part A, which was a monomial, and don't get the monomial confused with the binomial division. You got to do them different ways, so don't intermingle those and get them so that you're trying to do the binomial method on a monomial, because it won't work, okay? You get some real funky, strange answers when you do try to do that with it. So stay away from that part, and don't do that piece. So is there anything we need to go over with 5? 5 is a pretty straightforward chapter. Your test is on Monday next week, so make sure you do end up getting that done and getting it out of the way. So today we're going to take a look at the first part of Chapter 6. This stuff is not due until Wednesday next week, so work on Chapter 5 this weekend, get all your studying done for it, and then be ready to take your test then. So this stuff we're talking about isn't due until later. And then I've got a handout that will help you get going on the factoring we're going to do on the following Monday. So we're down to our last chapter. That makes it feel good. So we're going to take a look at 6.1a. Chapter 6 and 6.1 has 3 parts to it. So the first part is just trying to identify greatest common factors. So we're going to find greatest common factors in this one. And so if in greatest common factor, what it means, it means the largest number that will go into all of the terms. So it's going to be the largest number, or we could also put variable in here that will go into all of the terms. Now I know that makes you think big numbers. I'm going to get us a gigantic, great, big, huge thing, when actually it's kind of deceiving because it says greatest common factor, but it's actually the smallest number and the smallest exponent. So we're going to look for the small things. So if we, move this thing out of here, if we look at 7 and 14, what would be the smallest number that would go into 7 and into 14? To find the greatest common factor. So the greatest common factor that will go into 7 and 14 will be 7. So 7 is the greatest common factor. It's because 7 goes into 7 once, and 7 goes into 14 twice. So what it's going to let us do is when we find these greatest common factors, we're going to be able to pull them out, and we're going to remove them from whatever the number is that we happen to have. And so we want to look at them in that manner. So what about this one? 36 and 12. So what's the smallest number that will go into 36 and into 12? Evenly. Or the greatest common factor that would go into those? 3, 2, 9. Well, 9 goes into 36, but won't go into 12. But 6 goes into 36 and into 12. Okay. Anything bigger? 12. Yeah. 12 will go into 12 once, and 12 goes into 36 3 times. And so 12 is equal to my greatest common factor. Okay. Now, all the ones that you guys guessed, the 3, the 2, the 6, are all factors of these, meaning they're things that if I multiplied something by them, I would get 36 or I would get 12, but they're not the largest one of those, okay? So they're not the largest piece. What if you had,
Then why are we trying to find the smallest number?
well, because if I said the largest number, sometimes I get 36 as an answer. Sometimes you guys would give me back 36.
Number, it'll be 12 and 36.
would be 2, right? So really, I guess I should rephrase that. Maybe I should say, what's the largest number that would go into those? So it goes into 36 and into 12. So the largest number that would go into those would be 12, okay? But it's usually smaller than the 2 numbers that you have, so be careful with that part. So then, let's look at another one. What if you had 45 and 35? What will go into 45 that also goes into 35? And it's the biggest number that I can put in there. What would it be? 5. So my greatest common factor would be 5. Now, if you didn't see 5, you can take these and break them down to their prime factorizations. And then what you're going to look for is common stuff between them. The only thing that's common between these two is the 5. So therefore, the 5 is going to be my greatest common factor. So I can look at them and say, okay, what would end up being the number that would work with those? Do they only leave you with 2 numbers? No, unfortunately, they can give you 3 numbers. So what if we had 30, 45, and 75? 15? Everybody agree? You guys see 15 or not? So 15, it might be harder to see 15. So if we break 30 down, we get 3 times 10. 10 is 2 times 5. 45 is 5 and 9. And 9 is 3 and 3. And 75, we can break it down to 5 times 25. 5 times 25. 3 times 25, get it right, is 5 times 5. So 30 is 2 times 3 times 5. 45 is 3 times 3 times 5. And last off is 75, and that is 3 times 5 times 5. Now, instead of circling the largest group when we did the LCMs, least common multiples, we circled the largest group of all of these things. But this time, we're going to circle the smallest group. So the smallest group of 2's is no 2's. Okay? Again, looking at my columns, 2's, no 2's, and no 2's, so I need no 2's. 3, 2 3's, 1 3. I can get by with 1 3. 1 5, 1 5, 2 5's. The smallest group of 5's is a 5. So that's where 3 times 5 is 15. Now, not many of these are you going to look at and have to do this to. Okay? So if you didn't see 15, you'd have to go back through and try to figure out what that's going to be. All right? So when you look at it, you'd want to try to figure out what in the world are they giving me and what would be my value that I would come up with for that thing. So be aware of that. Now, sometimes they might give you something like this: 7, 25, and 35. So if I had that one, 7, 25, and 35, what's the largest number that would go into all of those? If you looked at it, what do you think? Guys thinking of one? So, okay, I can't put anything really. 7 is just 7 and 1. 25 is 5 and 5, and 35 is 5 and 7. But there isn't a number that's in each one of these that's common to all. So my greatest common factor is actually just 1. So I can't put anything in there. So it means I couldn't pull anything out of that whole value. So you want to be aware of this part. If you throw variables in the mix, are we good with this part, do you think? Just the numbers? Okay. So you're going to look just at the numbers first, and then you're going to go back and look at the other pieces. So if I go back and I do this, what am I going to have? Well, if I go through here and I look and I say I have 2x to the 4th y, and I have 4x to the 3rd y squared, and we'll put a 6 in there, x and y to the 5th, and I want to know what my greatest common factor will be. What would it be? So I look at just my numbers, 2, 4, and 6. So what number would only go into 2, 4, and 6? So, yep, the numerical part's 2, okay? Now, when you look at the variables, use the smallest exponent on the variable. And the variable has to be, or it must be, in each term. So if I look at my x's, I have x to the 4th, x to the 3rd, and an x. So the only thing I can pull out is the smallest one. So I can just remove an x. Okay, we good there? A y squared, and a y to the 5th. So the smallest y I have is just a single y. And this is my greatest common factor. This is the only piece that's in common to all 3 of those. Okay or not okay? Thoughts? Any thoughts on that part? So again, variables, always the smallest part on there. So then if you had, can I move my sheet? Yeah, okay. Now if you had a similar one, 2x squared, comma, 4x to the 3rd y, comma, 7x squared y cubed, can I pull anything out? So numerically, I have a 2, a 4, and a 7. So can I take any numbers out? Only thing is 1. X squared, x, and x squared. So I can pull out an x squared. No y, y, and a y cubed. So I can't pull out a y because I don't have a y here. So my greatest common factor of that whole thing is only x squared. Does that make sense? Okay, so I can't pull something out if it's not in everybody. So it's got to be in all of the terms or all of the pieces that you happen to have. So let's look at this one. How about this one? 18xy, 54xy, and a 90x. So what will be my greatest common factor with this one? What was it again? 6xy. 6xy. That's as big as we can pull out? 18x? We all agree? I think it's 18x? 18x, yes. 18x. Now when you look at this, I notice 9. And if I pulled out a 9 out of each of these, I'm left with a 2, a 6, and a 10. So 2, 6, and 10, there's another 2 I can pull out. Okay? So you can look at it that way too. So it depends on which one you happen to see and what comes out of there. So I can pull out a full 18 out of that one. So again, watch and make sure you pull out what you can. Can't pull out a y because that doesn't have one. Okay? So the y has to stay where it's at. How about this one? 3xy squared, 15x squared y squared, and 9x squared y. A 3xy? Everybody agree? Okay. Are we good? What do you think? Okay. That is all that you do in 6.1a. You're only looking for greatest common factors. So you're only pulling out whatever this thing happens to be in there that you're working with. So you want to be careful and make sure that you pull out your pieces that you happen to have. Do we need to do more of them or you're good? Because we're going to do more actually in 6.1b also because we got to remove them out of there. Do we need to do more? Are you good? You good? Okay. 6.1a is removing a greatest common factor. So now what we're going to do is we're going to take these things that we were given before And we're going to find that greatest common factor. And we found it on this one because all I did was take that last problem that we worked with, brought it down here, and what did we say our greatest common factor was? It was this thing. So 3xy. Now I'm going to remove it from what I have. So now I kind of go back to when we worked in chapter 5, the last section, the monomial division. Because basically what I'm doing is I'm taking this and I'm putting each one of these things over 3xy, zeros. Okay? And so then what cancels? So these cancel, the x cancels, the y squared, I'm left with a y. So we kind of practiced this back in chapter 5. So what's left here? 15 divided by 3 is 5. X squared and an x leaves me an x. A y squared and a y leaves me a y. We good? So far, so good? Okay. 9 divided by 3 is 3. X squared and x is an x. A y and a y is long gone. And so when I'm all done, this piece that's left over should not have anything of a common factor. If it does, I didn't pull out enough. Okay? So I have to watch and make sure I pull out what I need to in there and make sure I get what happens with that. So we're doing that monomial kind of division with these and looking at each one and coming up with those. Now you'll get to the point that you probably won't put it underneath. You'll just look, 3 divided by 3 is 1. X and x cancels. X squared and y leaves me a y. So you're just going to compare these. Remember, when you compare them, it's this exponent minus that. There will never be any denominators in this. If you get a denominator in here, you did something wrong. Okay? So there'll never be denominators. There'll always be just the piece that you got to factor out and come up with what that would be. Okay, so let's do some more of these guys so we get a good feel of what has to take place with them. What about this one? 4n plus 64. What's my greatest common factor? So we're putting 6,1a along with 6,1b. So what would be my greatest common factor? What can I pull out of there? A 4. Can I take an n out? Nope. So 4 divided by 4 is 1 and leaves an n. 64 divided by 4 is, 18? Oh, 16. So I get n plus 16. And that's my answer. So we're taking what we did in the multiplication that we did in chapter 5 and yanking it back apart and coming up with what those happen to be. How about this one? Negative 2a squared, or 2a to the 4th, plus 10a squared minus 4a. So we got to talk about this one for a minute because it starts out with a negative. So it leads with a negative. If that happens, I need to remove a negative. Which changes each sign. Or changes all signs. So it's going to change all signs within that. So what can I pull out? Well, I'm going to pull out a negative. 2, 10, and 4. What's my common factor between 2, 10, and 4? 2. A4, a squared, and an a. Just an a. And when I do that, a negative 2 divided by negative 2 becomes positive. A4 and a leaves me a positive a cubed. A positive 10 divided by negative 2 is a negative 5. A squared and a is an a. We good so far? Negative 4 divided by negative 2 is a plus 2. A and a cancel, so that becomes my solution. So this becomes my answer. Again, this type of stuff we're going to use throughout intermediate algebra too, so it's not just in here we're going to end up taking these things and factoring. So if you got that negative out in front, make sure that you pull it out. Here we'll do another one that's got a negative. Negative 20x cubed plus 5x to the fourth. What can I yank out of this thing? 5x, negative 5x to the third. So negative 20 divided by negative 5 is a positive 4. X to the third next to the third, gone. A positive 5 divided by negative 5 is a negative 1. If you want to put the 1 there, but we're not going to put it in hawks when we do that. X to the fourth and x to the third leaves me a x. We good? Nope. So when you put this answer into hawks, it's going to be a negative 5x cubed 4 minus x. Okay? With no 1. It'll tell you. Out of here? I'm going to pull out a negative because it leads negative. Okay? Then I look at 20 and 5. So the common factor between 20 and 5 is 5. X cubed and x to the fourth, smallest exponent. Okay? That's where. Yeah. I think what confused you is negative out in front. So as soon as this is negative, that's going to be negative. Yep. So you want to make sure that you end up getting those pieces in there and getting them to come out. What about this one? 11x to the third, y to the second, plus 11x cubed, y cubed, minus 121x squared, y to the third. What can I pull out of this whole thing? Pull out an 11. And what else? x3, x squared. Y squared, y cubed, y cubed. Yep. And so what am I left with? 11 and 11 cancel. X cubed and x squared leaves a x. Y squared and y squared, gone. 11 and 11 leaves a 1. X cubed and an x leaves an x, right? Y cubed and a y squared also leaves a y. 121 divided by 11, 11. X squared, gone. Y cubed and a y squared is a y. And so that becomes my answer. We good? Okay. So that would be what I would have there for that one. Okay. So it's again making sure that you've got your pieces coming out of them. Questions with those? Are we good or you need some more? What do you guys think? Want one more? One more. We'll do one more. And then we'll know that we've got what we're doing with these things. So one more. Negative 49 xy plus 7xy squared plus 35x squared y. So what can come out of this whole thing? Okay, yep, negative 7xy. And then what's left after it? So 7 is the only thing left in the front part. Positive 7 divided by negative 7 makes it a negative 1. X and x are gone. Y squared and y leaves a y. Positive 35 divided by negative 7. X squared and x leaves an x. Y and y, long gone. We good? Okay, good. So as long as we got all those, and again, this we're going to use, of course, in the rest of the chapter, because in the rest of the chapter, we're going to always look to see if we can pull something out first. That's always where we're going to start with factoring. Can I pull something out of it before I go any farther with it? If you can, it makes your life a lot easier because some of these problems get some fair-sized numbers involved in them. So you want to make sure that you do that. with them. So the last piece for today, we're only going to do 6.1 A, B, and C, and then my little extra sheet that's going to help you get into doing the other factoring we're going to do the following week. So 6.1C is taking a look at grouping. So factoring with grouping. And we're going to use this in 6.3B. So that's where we're going to use it at. I know it kind of hangs in here and it's kind of stuck in here and you're kind of like, what in the world are we ever going to do with that stuff? But we're going to use it in that section. So it's coming up. It's not too far off. So actually it's next week, Wednesday, when we'll get into that part. But we're getting there with these. So let's see. So what grouping means is no longer do you have just a single monomial kind of thing that you're going to pull out. We're going to pull out a binomial. But the binomial will show up using the factoring we did before. So it might look like this. So when we look at this equation, what do we see? Well, we see y times this piece and we see 2 times that piece, but don't multiply them. So do not multiply. Leave them as they are, okay? Because what's our common factor? So our common factor, the common piece that's shared between these is what? X plus 4. This piece and this piece match each other. So there's a match there. So what that means is if there's a match here, that means I can pull out an x plus 4. So if I were going to do this and I put this whole thing over x plus 4, what would happen is that whole piece will cancel out, leaving me with y. If I put this piece over x plus 4, these two pieces cancel out, leaves me with a 2. So what I've done is I pulled x plus 4 out of it, and now what I have is 2 binomials. So I've got 2 binomial pieces in here that end up being my 2 factors. Is that okay? Later on, when you go to take your test in this part, I can guarantee somebody's going to look at this and you're going to say, what? How am I supposed to do that? Because it just gets to be, it's pretty simple of pulling that x plus 4 out, but you kind of forget about it later on. But I'll try to remind you so that we can remember that we got to pull that piece out of there. So what about this one? A times x minus 4 plus b times x minus 4. So again, what would I have to pull out? Well, those two match. So x minus 4 comes out, and when I compare it to this one, that cancels. So I'm left with just an A. When I compare it with this piece, these two match, so they cancel. Leaves me with a plus B. Okay, you're not okay. Okay, good. All right, so then what does this thing look like if I FOILed it? Well, if I FOILed it, x times A is AX, x times B is BX, negative 4 times A is a negative 4A, negative 4 times B is a negative 4B. So when I FOIL it, it looks like it's kind of odd. Can I put anything together? What do you think? Anything gets combined? No, they're all different. So if you see a 4-termed expression to be factored. So it's got 4 terms. Nothing can be combined, nothing is separate. So if you see that, then we got to do another method to factor it. So to factor this one, what we need to do, and let me get it written over here, and I would have it on the back side. Minus 4A minus B. If I want to factor this, if that's what I started with, we know it's not that, but if I wanted to break it back apart, what I would do is put in groups of 2. So I'm going to go up here and I'm going to put those first 2 together and I'm going to put the last 2 together. Leave the second symbol with the second binomial. So make sure you include it. Now that's one thing that Hawkes doesn't do. If you went to Hawkes and you looked at Hawkes' explanation of it, they don't leave this with this, okay? They just kind of leave it hanging out there. They would put a parenthesis here and say factor it. And when you go to factor it, you find stuff that doesn't match. So second step is factor each binomial separately. So if I factor this one, what could I pull if that's the only thing I had? And that's it. What could I pull out of it? I can pull a x out. And that's going to leave me with a plus b, because x out of a is a. X out of bx is b. And what can I pull out of here? Again, using those skills we had in 6.1b, I can pull out a -4. And when I do that, -4 divided by -4 is 1, and an a is left. -4 out of a -4b is a positive 1, and there's a b left. And when you're all done, the 2 binomials should match. Okay? And then last of all, pull the common binomial out, or factor out the common binomial. So if I factor out the common binomial, a plus b, I get left with x minus 4, and I'm done. Okay? So the steps are longer than the process, than actually doing the problem. And so my steps end up being longer in here than what I need to actually do it. So let's go through another one. What if we had ax plus ay plus bx plus by? If that were my one to factor. So first step, put in groups of 2. So I did that. Second step, factor each part. So I'm going to pull out what out of the first piece? Can I pull out of there? I can pull an a out. Leaves me with x plus y. Second one, the common piece in there, I can pull out a b. Leaves me with x plus y. These two match, and they need to match. If they don't match, we did something wrong. So x plus y, pull it out, leaves me with a plus b. Okay or not okay? Okay. One more in there. What if you had x squared minus xy minus 5x plus 5y? What's going to happen to it? So we group it in twos. So what do I get? Do you guys have an answer? Maybe you already got an answer down here. What would my answer be? If you've got one. Do you have x minus, what was it? Oh, okay, you're up here. Okay. And the other one?
Minus 5.
Mm-hmm. Okay, yeah. So when I break it apart, I get x minus y, and I get x minus 5. Okay? We're good? Need to do more of those? Or you think we're okay? Okay. Now, they do in here put in one little twist. Always this twist. I don't know. They just enjoy giving you things that end up being a little bit different. So if I had 6AC minus 4BD plus BC minus 24AD. So if that were my problem to work with, and I'm just tootling along with these and they're working out great and I'm just going through and putting the combinations and I go through and I put this together and that together and I go back and look at it and I'm like, God's, wait a minute, can I pull anything out? Well, I could pull out a 2 out of here, but is that going to help me? If I pull out a 2, what do you think? Is that going to help me at all? I get AC, I get 3AC, we'll do a 2. Pull out a 2, I get 3AC minus 2BD. Okay, what can I pull out of here? Well, I look at that one and I look at the whole thing and there's nothing I can pull out of there, right? I can't pull any pieces whatsoever out of that one. So then I'm stuck. So then you might say, oh, well, it's not factorable. But what we've got to do with these, and they stick them in there. So if you ever run across this and you get to this point and you can't do anything else with it, go back and see if I flip-flop 2 pieces, can I then factor it better? So if I flip-flop these 2, plus BC minus 4BD minus 24AD, can I factor these now? So let's see. So I group in 2s. And what can I pull out of this first piece? Is there anything I can pull out of that first piece? I can pull out a C. Well, it's a little healthier than the last one. 6A plus B. What can I pull out of this one? Is there anything I can pull out of that one? -4 and a -24, so I can pull on -4. And I can pull also out a D, right? So what am I left with? -4 divided by -4 is gone. D and D are gone, so it leaves me a B. -24 and a -4 leaves me a +6. AD, and I can pull out a D, so it leaves an A. So now does my pieces match? Do they match? Yeah. They're identical to each other because this just needs to be flip-flopped and have A plus B. But I can do that because they're both positives and it's not going to change anything. So really my answer is 6A plus B times C minus 4D. Okay, so if it doesn't factor, switch two terms around. Then factor. So if you can flip them around, try that. Okay, here's another one. One that's going to work here. 4AC minus 9BD plus BC minus 36AD. Does that one factor? Your first glance, 2 pieces, the first 2 together, If nothing factors out of that, then I got to do some switching. So is anything, can I switch some stuff around? So if we just flip-flop BC with negative 9BD, we might be getting somewhere. So 4AC plus BC, whoops, minus 9BD minus 36AD. Now if I group them, I'll be good, okay? So they sneak them in. So just be aware of that they kind of like to give you strange stuff at some points. So if I pull out a C, I get 4A plus B. Down here, pull out a negative 9 and a D. I'm left with B plus 4A, and they both match. So 4A plus B times C minus 9D. So they get a little tricky, but not too bad on trickiness. What do you think? Yes? No? Okay. The last piece, once in a while, if they give you, let's say we get this one. We get AY minus 6 plus 3A squared minus 6A. And once again, I can't take anything out of the first. When I just look at the first two terms, nothing factors out. So let's do my flip-flop here. Group them in twos. And what can we pull out? First one, I can yank an A out. Leaves me with Y plus 3A. Last one, I can pull out a negative 6. Leaves me with 1 plus A. But what happens? Well, this and this don't match each other, do they? They're completely different. So this is not factorable. So I can't factor it. I can't do anything with it. So I can't change it. I can't manipulate it. I can't get it to do anything. So we just have to put on there not factorable so that we can't end up doing that piece. Okay? So you want to watch that and see what happens with it. Okay? So be real careful in making sure that you get your pieces in there and get your stuff to come together. So you got to be careful with that part and watching those so that you get an idea of what goes with that. Okay? What do you think? Think you can handle those? Okay. So do some flip-flopping and switching some stuff around and see what takes place with them. I don't think, I was trying to remember whether they, and I don't think they do. I don't think I had any in here. It's just that switch of those two that you have to make sometimes. So other than that, I think we're good with that part. Okay, so the next thing is the handout that I want to give to you. This is extra credit. So I think time right now is kind of a good time to fit some extra credit stuff in here. And this is going to make a world of difference with your factoring once we get to it in the next sections. We used to have a math lab that we do with basic algebra, and we don't have that anymore. And so we need to take a look at some of this factoring things. So it gets you thinking about what we've got to do with these. So you got two sides to this. One side is x squared plus 11x plus 24. I got that side? And of course the other side's got negatives in it, and we'll talk about those negatives here in a second. And you can take this with you. It's not that you got to get it done. If you get it done today, then you don't have to worry about it. Okay? So there's going to be some time to work on some stuff after we get done with the lecture piece today. So you might want to finish it up and get it back to me. I've got answer sheets up here, so if you wanted to take a look at those, you could. So what we're looking for is when we get into doing binomials or trinomials and factoring those, we have different pieces. If you've got a single x squared term out in front, then you have a middle term, and then you have a final term. This final term right here ends up being things that multiply. So values that are going to multiply are factors of 24 that when you multiply them are going to add to my middle term. So if you look just at 24, let me grab another sheet of paper over here. 24 has a lot of different factors. Because if we look at factors of 24, it could be 1 times 24. It could be 2 times 12. It could be 3 times 8. It could be 4 times 6. And then when you get to 5, 5 doesn't go into it, and then you start repeating. So you get 6, and then you get 8, and you get 12. So you got all the factors there. But my factors need to be special. They need to be special because they need to add to 11. So what factors in here would add to 11? So 1 and 24, if I take 1 plus 24, I get 25. That's not it. 2 plus 12, I get 14. 3 plus 8 gives me my magical 11. Okay? So what this means is these two factors, or these two pieces that you have here of 8 and 3, become the numbers in your binomial, or when you factor it to binomial. So the x is an x squared, so it's just an x and x, and then my factors are going to be 8 and 3 that I would put in there. So let's look at another one. What would this one look like? If I looked at it as a polynomial, it would be x squared. The middle term is what they add to, and the last term is what comes out at the end. So you would put that piece in there, and these are kind of pretty easy to find when you work with them because you get that middle piece. So what do we get? What are factors of 28 that add to 11? So you could go over here and put 28 times 1. You could go 2 times 14. I can go, 3 doesn't go into it. 4 times 8. No, 4 times 7, sorry, is 28. And then 5 doesn't work and 6 doesn't work. So add these together, 2 plus 14, that's not it. 4 plus 7 is 11. So my answers are 4 and 7. And my two binomials are going to be x plus 4 and x plus 7. So it helps me with my factoring, because we're going to break them apart next time. We're going to be given this piece, and we need to find these pieces. So let's do one more over here on this side. Let's try that one. 54. So my binomial is x squared plus 15x plus 54. So what are some factors of 54 that add to 15? Oh, 1 in 54, that's not it. 2 goes in there because it's even, and that gives me 27. That's not going to be 15. 3 goes into 54. A 16 times, or 18 times. 18 plus 3, that's not 15. 4 doesn't go in there. 5 doesn't go in there. 6 goes in there. 6 times 9. And 9 plus 16, or 6 is 15. So my answers are 9 and 6. And my binomials. Got the idea, you think? Are you going through them and figuring them out? And you just kind of go through and do that with all of these. But it gives you some good practice with what you have happening in there. The back side, so the flip side of the page, let's take a look at it for a minute. Let me get my pages together here. The flip side is going to throw in some negatives in here. So when you set up your your polynomial over here, or your trinomial, you're going to have x squared minus 6x minus 24. So go with your signs. The other side of the paper, everything's positive. This side, we're going to get some signs involved. So it makes it a little different, because what happens here on this part is that, this is the back side, so we know where that happens to be, is I got to take in things that multiply to give me a negative 27, but at the same time add to give me a negative 6. To get a negative 27, one factor has to be positive and one factor has to be negative. Okay, you understand that? To get a negative 27, one's positive, one's negative. So what are factors of 27? Well, if I go through here, I could have 27 times 1. I could have a negative 27 times a positive 1. I could have 3, negative 3 times 9, or a negative 9 times 3. Or I think that's it, because 27 doesn't have any other factors. So which of these adds to a negative 6? Well, a plus 27 minus 1 is 26. A negative 27 plus 1 is a negative 26. A negative 3 plus 9 is a positive 6. And a negative 9 plus 3 is a negative 6. So that becomes my factors. Okay? Now, do you have to go through all of these? You're looking at it and saying, oh my word, I come up with all those factors? No, because if your middle term is negative, if this middle piece is negative, that tells me that the only factors I want to look at are the ones that give me my bigger number is negative. So therefore, the only ones I want to look at is a bigger factor of negative 9 and a positive 3, or a negative 27 and a positive 1 to get that middle number. The more you practice with them, the better you get at it. So let's look at this one. Positive 10 and a negative 7. Multiply to get positive 10, but add to equal a negative 7. How in the world could that be? I've got two different signs. This is positive and that's negative. How can I get an added negative and a positive over here? Well, the only thing that you could get is both factors must be negatives, because a negative plus a negative will give me a negative 7, and a negative times a negative gives me a positive. So the factors are 2 and 5. Negative 2 plus a negative 5 does equal a negative 7. And so my binomial is going to be x minus 5 and x minus 2. So my signs would be the same. Okay. Let's see, we did one with that part. That one's a positive. Let's look at this one. Negative 8 and a negative 2. Oh, I forgot my binomial over here, or my trinomial, x squared minus 7x plus 10. This one is x squared minus 2x minus 8. So factors of a negative 8 that when they're added equal a negative 2. What would we get? Nope, because a negative 1 times a negative 2 is not 8. Oh, negative 4. Okay, I missed your negative there. Negative 4, and what was the other one? And a positive 2. So x minus 4 and x plus 2 would be what you get. Okay. One more, and I'll let you guys go at it. See what you want to do with them. How about that one? Negative 72 and a negative 6. So I have x squared minus 6x minus 72. paper here. So if this is negative in the center, that means my negative factor needs to be bigger. 72's got lots of different factors to it. And you don't need to write them down. You can go through them in your head if you want to, and adding at the same time. We know all of these are going to be way too big for the middle term. So negative 12 times positive 6 is what's going to give it to me. So I get the factors of negative 12 and x plus 6 for those. Questions on this part? You think you can do it? Use your calculator to help you with it if you need to. This is the base ground floor for almost everything else that we do in this whole chapter 6. So if you get this piece down, we've got a whole good chunk of what factoring is all about. And this doesn't add a whole lot of things of looking and saying I'm actually doing factoring. It's just looking at combinations of what you happen to have. So if you do this, it's going to be worth 8 extra credit points. So like making up 2 homework assignments. So it's kind of worth 2 homework because each side of the page is like a homework assignment. So it's extra credit of 8 points. So if you get it done by Wednesday next week, okay, or you get it done today and you turn it in to me, you got your 8 points, okay? So however you want to do that. All right, I'm going to stop this recording stuff up here. Oh, yeah, let me get out of here for a second.